Google Cloud Innovators is by your side every step of the way, bringing you tools, access, and recognition to optimize your journey into the cloud. Receive weekly newsletters, attend sessions with experts, redeem no-cost cloud training, and get discounts to attend key Google Cloud events. Leverage your skills and optimize your time on the platform meant to help innovators like you succeed. Learn, build, and grow.
Hello and welcome everyone. Thanks for joining us today to our webinar on how to migrate MySQL to Spanner to unlock multi-modal capabilities. My name is Saval Georgiai, or SAPS. I'm an architect and I'm joined here by Manit Gupta.
Hi everyone, nice to meet you.
So for today, we have prepared a two-part agenda. First, we are going to do a quick rundown on what Spanner is actually and how it matters for MySQL users. But right after that, we will dive into the weeds. First, we are going to show you how you can unlock Spanner if you're coming from MySQL, meaning how you can migrate your schema and data to Spanner using our migration toolset in order to be able to elevate to like this unlimited scale and open up multi-modal capabilities. We will also dig a bit into the scenario if you're operating a sharded large-scale MySQL cluster and how you can move that one also easily to Spanner. Then in the second part, once we have the data inside Spanner, we are going to put Spanner graph analysis on top of the data. And we are going to do some advanced analytics on operational data using Spanner's full text search as well as Gemini models to identify in our scenario sanctioned individuals and understand their behavior. But first things first, what we are seeing is that the nature of applications has changed. Innovation is accelerating, and this means our customers are dealing with all sorts of new kinds of data. This in turn cranks up the complexity, and we often see them having to bolt on like separate systems alongside their main operational databases just to handle these new and interesting things they want to do. Then there is the challenge of unpredictable scale. So our customers, for instance, in retail dealing with Black Friday type of events, or in the gaming space handling new game launches or promotional events. These things are very complicated, both operationally from the standpoint of managing the scale, but also from the cost standpoint. So over-provisioning is really something that you don't want to do for the whole year when you're just accommodating like an out-of-the-ordinary peak workload. And of course, the expectation today is always on access. So our customers and their users expect to be able to get to their data and use their applications whenever they want without like interruption. And with these increasing demands, the IT budgets aren't really growing to match. So development teams are being forced to do more with less. And this means being able to have a cost-effective solution that can offload some of that cost of complexity to Google could be a key benefit. Finally, we can't forget that some industries, they operate under a significant level of regulatory scrutiny. So a lot of the applications we see with Spanner are in those regulated industries like financial services or healthcare, where meeting those compliance requirements is absolutely critical. To address the challenge with scaling, applications were really the first ones to address this. Containerization, Kubernetes have allowed app teams to scale out applications nowadays in a relatively easy manner. And if those applications are specifically stateless, you can just add more instances of the application and handle more traffic. But what happens when the systems get bottlenecked at the database level? So if you can't scale the database to meet the front-end load, you're going to have issues scaling out like the entire system. So we see this with a lot of our customers who are modernizing their applications, building microservices. But now their database becomes the bottleneck and turns into potentially an urgent problem to innovate and deliver value. And this is especially true for MySQL. So you have to think about it. It was built and architected in a different area for different use cases, and it wasn't necessarily designed for the scale and types of challenges that we just have seen in the previous slides. So with this increased scaling and availability requirements comes like the additional cost and risk that is often translated into the database administrators, application teams to support and to handle. For instance, maintenance windows or schema changes, they require downtime that you need to plan for. Then maybe enabling high availability across regions could become a very complex and expensive task. Same challenges apply for scaling. I need to increase the capacity of the servers, meaning adding more CPU, RAM, bigger disk, faster disks. And if that is not cutting it anymore, I need to go down the route potentially of sharding, which opens up a large range of challenges down the road. Then I need to work maybe my way through handling read replications. Then I step potentially into lag-induced consistency issues, so on and so forth. One thing I want to clarify here so you don't get me wrong. So MySQL is a very mature operational database, but we're seeing a lot of customers having trouble scaling to meet their needs. And ironically, Spanner's original motivation was us trying to scale ads internally on MySQL, battling these availability, scalability, and operational challenges. So Spanner really comes from the angle of trying to run scaled out production MySQL applications ourselves. So what is Spanner exactly? Spanner is a fully managed enterprise-grade database that combines relational semantics, meaning all the core relational features such as schemas, ACID-compliant transactions, and SQL, with built-in sharding and seamless horizontal scalability, providing up to 5 nines of availability. So with Spanner, essentially has zero maintenance requirements. The concept of downtimes doesn't exist. You get virtually unlimited read and, very importantly, write scaling. The resources are elastically provisioned and released for cost efficiency purposes when you don't need them anymore. And a really nice thing about Spanner is also it scales linearly. So that means you get predictable costs that you can budget for. And also one thing I want to mention here is at the surface, Spanner looks like a relational database, but a lot of our customers are using Spanner actually for simple key value workloads, as it also ships like a wide range of features such as JSON data types along with JSON convenience functions to cater for these semi-structured data use cases. And let's say despite Spanner's comparatively young age, it's a battle-proven technology used internally for a wide range of Google products, as well as extensively by our cloud customers, even in heavily regulated industries like finance. And just to get an idea about the magnitude of operations, Cloud Spanner processes over 4 billion of requests per second at peak times. It now manages more than 15 exabytes of data. And performance-wise, you should expect around less than 5 milliseconds of latency for like simple database operations. Now, what has happened recently is that we have started to reimagine Spanner by bringing a range of new features to the product. Just to name a few. We have launched Spanner Graph, which is a scale-out graph database supporting native graph querying capabilities directly on your operational data with full SQL interoperability. We released full text search for Spanner that provides contextual relevant search results. We also added vector search to power GenAI use cases. And in general, we have also deepened the integration with our analytics stack. And the overall idea is to bring a fully interoperable multi-modal data system to enable like a wide range of use cases combined with the operational simplicity of Spanner. But now let's get started with the demos and let's go into the details. First part is what we are going to do is we're going to take an existing MySQL database and move that to Spanner in order to unlock all these Spanner benefits and enable multi-modal use cases on your existing workload. The demo data contains a data set that reassembles something like a retail banking system used to manage customer information, like their bank accounts, loans. It tracks like key transactions like transfers and loan repayments along with an audit trail. And once the schema and data have been migrated, we're going to analyze the data with Spanner Graph to understand, for instance, how money is flowing between customers, which might be, as an example, helpful to uncover money laundering patterns. We're also going to do some advanced analytics directly on top of this operational data with full text search to find sanctioned individuals which are maintained in BigQuery. And we're also going to let Gemini analyze their behavioral patterns in the audit logs. But let's get started with the migration, Manit.
Thanks, Abs, for the great introduction on Spanner. In today's demo, I will go through two steps. The first step is to actually migrate a sample MySQL application, which is what Sabs described, to Spanner. We will look at the various processes that are involved during the migration. And once the migration is done, we will start looking at how it systematically unlocks various multimodal capabilities that Spanner provides. We will start with Spanner Graph and then move on to full text search, federated queries, as well as how to use AI to leverage auditing of your business logs. But before we get into those details, I want to quickly recap what a typical migration journey for a customer looks like. This helps us in building some context behind what are we going to do. So typically, a customer goes through 6 discrete steps when they are undertaking a journey of migration to Spanner. The first step is assessment, where the customer wants to understand whether Spanner is even a good fit for their business use case. We have developed tools as part of this leg, which helps customers perform both schema and application assessment to get a sense of where Spanner works for them and where it doesn't. Similarly, we also provide an estimate on the sizing and the total cost of ownership when you migrate to Spanner. Armed with this information, most customers are able to make a decision if Spanner is worth exploring or not. In the next stage, we migrate the schema to something that works on your source database to something that is compatible with Spanner. During this journey, the customer essentially starts developing a beginner understanding of how Spanner works, as well as what are the specific Spanner optimizations that they can perform to take advantage of the full breadth of functionality of Spanner. The schema migration is done with the help of a dedicated Spanner migration tool, which apart from schema migration also helps customers with a variety of other tasks. Once the schema migration is done, the next step for the customer is to look at an application migration. This is often one of the largest steps of the migration journey because customers migrating to Spanner come from different backgrounds such as healthcare, finance, gaming. As Sabs has talked about, each application migration is unique. That being said, Spanner has a rich ecosystem of support for various ORMs in various languages, as well as language-specific client libraries to make life easy for the customer. Once the application migration is done, the next step is optimization. This is where we move from having compatibility on Spanner to performing on Spanner. Up until this stage, we have a schema and an application that works on Spanner. However, Spanner provides a large variety of features to optimize both your schema and application to take advantage of the full horizontally scalable capability that Spanner provides. An example of this could be, for example, interleaving. This is also often a good time to explore additional multimodal capabilities that might unlock new business use cases that you haven't yet thought of. Once the optimization is done and the application is in a shape where it performs well on Spanner, we move to the next big task, which is data migration. I will talk about data migration specifically with respect to sharded databases in the next few slides. So I'm going to skip over this for now. Finally, once all of the data is on Spanner, we talk about how life looks at in Spanner essentially. This is where we take advantage of the horizontal platform level capability that Spanner provides in monitoring your database. Not only do you get scale, but you get platform level observability, data protection, disaster recovery features to go along with it. Finally, security is also important. Spanner provides built-in controls such as fine-grained access control to ensure that only the relevant access is provided to relevant parties. Okay, so now let's get started with schema migration and some basic concepts. As I mentioned before, the schema migration is done with the help of the Spanner migration tool. Spanner migration tool, or SMT, is essentially a user deployable binary that is available to run locally on your machine as well as available via G-Cloud. The Spanner migration tool ships with a neat UI that helps you load your schema from your source database, perform iterative conversions on the loaded schema, convert it to a Spanner compatible schema automatically, and finally load it into Spanner. The schema conversion process is iterative in nature, and Spanner migration tool provides you a lot of hooks to change the schema as per your needs. Some common examples are changing the name of a column, changing the name of a table, adding new auto-generated keys, removing extra indexes, and so on and so forth. Once you are done with the schema migration, you can move to the data migration phase. One thing that I would note is that Spanner migration tool implicitly manages the schema awareness of your data migration. So for example, if you have renamed a column during the schema migration, the data migration is already going to be aware of this change and is going to map the data from source to Spanner accordingly. Let's move on to the data migration leg. The data migration consists of two parts. One is called backfill, the other is called incremental. The backfill migration is about moving your data that is at rest, that is already in the source database, to Spanner efficiently. We do this by using a bulk migration pipeline. The bulk migration pipeline essentially partitions the data on your source database into discrete units and then parallelly reads them and writes them efficiently on Spanner. We are able to do this by using automatically selecting an index or a primary key of your source database and then using it to partition the data. Once the bulk migration is done, almost 90 to 99% of the data is already migrated to Spanner. The next leg of the forward data migration is change data capture or incremental migration. This is a streaming migration pipeline set up automatically by the Spanner migration tool, which helps customers live replicate the data from source to Spanner with a low latency. We do this by setting up change data capture on your source database, consuming the change data capture, and then applying it to Spanner in an eventually consistent manner. The end result of the forward data migration is that you have all of your static data migrated to Spanner, and you have a live replication pipeline, which is writing all the changes that are happening on your source database to Spanner with a low latency. Next, I want to talk about reverse replication a bit. This is often undersold, but a quite important part of the whole migration journey. We know that migrations are often a complex affair. Things can and do go wrong. For this purpose, the SMT tool also provides you with the reverse replication or a fallback utility that seamlessly writes the results of that seamlessly writes the writes that are happening on your newly minted Spanner database back to the source database. What this means is that if due to any business or operational reason you have to switch back to your old source database, you can seamlessly do that while avoiding catastrophic business failure. The reverse replication pipeline reads the Spanner change streams and applies these change stream logs back to the source database. It has the capability to fan out the writes to the Spanner database back to the individual source charts as well by using a customer provided sharded key. This is where the migration tooling for Spanner really shines. Not only does it provide you an ability to consolidate the data from your sharded MySQL or any other sharded source database back to Spanner, it also allows you to fall back on your same sharded database in case things go wrong. I would also want to highlight that this entire migration happens in your GCP project in a completely transparent manner. All of the infrastructure that is created by both the forward and the reverse replication pipeline is transparently visible to the user, and is managed by Terraform under the hood. This means that while you don't have to worry about the individual state of each of these GCP resources that we spin up on your behalf, you still have full control and visibility over what the migration pipeline is doing for you. Okay, let's get to the exciting bit now. Up until now, I have talked about large-scale production migrations of sharded databases to Spanner. But how does a customer even start? For this reason specifically, we have built something called as a POC migration. POC migration is a lightweight utility that we have embedded inside Spanner migration tool itself, which helps customers quickly migrate their data from their source database to Spanner in order to start learning about Spanner. How a POC migration works is that it directly connects to the source database, pulls the MySQL data from it, converts it on fly to a Spanner compatible format, and then writes it to Spanner. This works very well for iterative experimentation when new customers are trying to learn about Spanner, and is typically suited for small data sets of ranging less than 10 GB in size. Let's look at the demo scenario now. In the MySQL migration demo, we will be migrating the schema that Sabs talked about with some small sample data to Spanner. We will do this with the help of the POC migration approach using the Spanner web UI. We will first convert the schema to a Spanner compatible schema and then migrate the data. Let's get started. As you can see on this screen, as I talked about earlier, Spanner SMT is a user deployable binary. This means that it is just a gcloud command that I can run to basically spin up the UI. Gcloud spanner migrate web is the command that I have already run just to save some time to spin up the UI. As I can see, the UI is already spun up on my local machine at port 8080. So let's head over to this web UI and look at what it looks like. This is the first landing page of the Spanner migration tool. This is where you would configure your project ID and the Spanner instance ID where you want to do the migration. Let's get started while connecting to a database. I'll click on the connect to database option and select MySQL because that is the migration that we want to do today. Let me fill in the details. One of the great flexibilities that a user deployable binary gives to the customer is that they can run it anywhere that they want. In this example, just to simplify the connectivity process, I am running a client VM, which is running in the same VPC as my database. This means that I can connect to the database using a private IP in a secure manner. Let's fill in all the details and test the connection to Spanner. As we can see, the Spanner migration tool was able to successfully connect to the source database. Let's click on connect and watch SMT in action as it converts the source to a Spanner schema. So right now, behind the scenes, SMT connected to the source database, pulled in all the information belonging to the GraphDB database, and converted their schema to Spanner. Let's look at a couple of examples. Accounts is a table which contains 4 columns. SMT tool has automatically converted these columns to Spanner compatible columns. A specific example is that ID column of type big int has been converted to an ID column of type int64. Similarly, a type column of type text and size 65535 has been converted to a string max column. I can even go and look at the SQL that is generated as a result of this conversion. So in this example, SMT has converted accounts with the primary key as an ID and all of these 4 columns as the values. Not only does SMT does conversion, it also provides you some key recommendations. Let's look at a couple of them. So in this example, we see that Spanner highlights that there are some things that will need to be done manually. While in this example, Spanner gives you a suggestion that the account audits table can be interleaved inside the account table. Interleaving is a Spanner specific concept, which I will not go into right now, but suffice it to say that the SMT tool not only does the automatic conversion, but it also provides you recommendations on how you can optimize your schema. Once we are satisfied with the schema that we have migrated, we can move on to prepare migration to actually migrate this data to a Spanner instance. Today, we want to perform a POC migration and migrate both of our schema and data. So let's select that. Next step will be to configure the name of the database that we want to migrate to. So let me write the GraphDB demo database here. This shows all the details of the migration that I'm trying to perform. And then when I click on migrate, the migration starts. SMT works in two phases. First, it migrates your schema to Spanner, and the next, it migrates your data to Spanner. Once all the data has been migrated, it applies any foreign key or index constraints that you had in your original schema. Let's look at the Spanner database that has been converted and migrated by SMT to see what it looks like. Okay, so as we can see, all the tables that were there in the source database are now on Spanner. I can look at the equivalent DDL to inspect the DDL that has been created by SMT on the user's behalf. Similarly, I can use the Spanner Studio to check if the data has been migrated. Let's run a sample query. Okay, so in this example, we can see that all the 10 rows that I requested for are visible. Okay, so in summary, we were able to do a sample migration from MySQL to Spanner, where we converted the schema to a Spanner compatible schema and then migrated about 10,000 rows from the source MySQL to the Spanner database. The next step will be that now that we have a bunch of these relational tables written to Spanner, how can we unlock multimodal business use cases that we couldn't really think of earlier when we were on MySQL? The first of these is analyzing our data using graph capabilities. So let's talk about Spanner Graph for a minute. Spanner Graph is a new purpose-built graph query system designed on top of the existing relational semantics that Spanner already provides to provide full interoperability between the two data models. This effectively means that your data is not duplicated, while at the same time, you get all of the same benefits of other purpose-built databases that are specifically designed for graph use cases. This is like best of both worlds. Not only do you get to maintain your existing use cases, but you get to design new use cases on top of your existing data. Let's look at how we can do some of that. In the beginning of this presentation, Sabs walked us through the ER model of the demo that we are doing today. We had roughly three entities, which were person, loan, and account, and they had a bunch of relationships with each other. For example, a person could have some accounts, and accounts could have multiple transfers against each other. If we think about it, these kind of relationships actually lend very well to a native graph structure. And therefore, we can sort of derive a loose analogy between a concept that exists in the ER model and how it translates into a graph model. To give an example, an entity in an ER model loosely translates to an edge, a relationship loosely translates to an entity translates to a node, a relationship translates to an edge, and an attribute translates to a property. So this ERD, when viewed as a graph, sort of becomes this three-node graph structure. If you look at this graph, we have a person's node, we have an account node, and we have a loan node. And the edges of this graph show the relationship between them. So for example, a person can own an account, which is denoted by the owns edge. And two accounts can have multiple transfers again between them, which is denoted by the transfers edge. So all of these relationships are actually captured in Spanner using a new DDL, which defines something called as a property graph. So which is on the right side of the screen. If you look, we define a couple of node tables and a couple of edge tables, which loosely translate to the graph on the left. We have three nodes, which are person, account, and loan, and we have three edges, which declare the relationships between these nodes. Once this property graph is defined, Spanner is now able to do graph queries on top of the existing data. Note that there is no underlying duplication of data that takes place. Let's look at a couple of examples, and we'll shortly go through a live demo to see them in action. But there are certain things that a graph queries are very good at. So first example of that is node and pattern matching. You can actually write a query that literally looks like an English command, which describes a specific relationship, which otherwise would have been very hard to model in a SQL query. An example of this would be to find the account owned by some person and then discover all the loans repaid by this. I will move over this slide because we will look at it in a demo, and that is where we will go into more details. Similarly, another use case that graphs are really good at is path traversal. So if you want to find out the number of transactions that have happened between two accounts and what are the different intermediate accounts that are involved during this transaction, graph makes it really easy. As all of you must have done in your college level, you would see that this is a classic path traversal problem. And now we can easily run queries to describe the path traversal on top of our existing relational data. Let's see some of this in action again. Firstly, I will move back to my graph demo database. In order to run graph queries, I first need to create the property graph model that I talked about. So let me quickly create that graph. This graph is identical to the one in the slides where we have 3 node tables as well as we have 3 edge tables. Okay, so but we now have created this graph, and below we show that the update has been completed. Correspondingly, on the left-hand side, we have a new graph created under the graph entity, which shows that a fin graph has been created. Further, if we drill down, we can see the same 3 edges and the nodes for this graph. Okay, now that the graph is created, let's start running a couple of queries against it. When we run the first query, which is where we are trying to find accounts owned by the person Jacoby, and then find the loans that he has repaid, the number of repayments he has made for a particular loan. When we run this query, we see that Spanner automatically uses a visualizer to visualize this, the output of this query for us. In this example, we can see that Jacoby is actually a person with ID 263 who owns an account which was opened on this specific date and has multiple repayments against the specific loan account 17803. Note that you have to use the save to JSON method to visualize the output of your queries using the Spanner graph visualizer. Now let's do something more interesting. We have been talking about leveraging the cross-cutting capabilities of Spanner to combine both relational and graph workloads quite a bit in this talk. So let's see that in action. This is an example of a query where a graph query returns a relational result. What this query does is that it looks for transfers between accounts and then groups these accounts by the number of incoming transfers per account. Once we have this mapping, it then adds a second query where it tries to find the persons which own this specific account and then display their owner names as well. So the result is essentially a table, but how this is executing is as a graph query. So when we run this graph query, we actually get a relational output, and this is where Spanner really starts shining. You can use a graph query to get a relational result. You can use a relational query within a graph query to get a relational result or a graph result. So the possibilities are endless. You get to combine vector, graph, relational, as well as full text search all together to come up with a new modern application that works only on Spanner. With this, I would like to hand over to my colleague Sabs, who will take you through some other multimodal use cases.
The people that we are going to discover here in this analysis are going to be real. So we wanted to be really mindful about that. What we don't want to do in this search for a sanctioned individual is to search for exact name matches. So we want to see if there are like suspiciously similarly sounding or spelled names that we want to take a closer look into. For that purpose, we want to wrap our full text search with SoundX around the data in order to be able to efficiently search those names. Then we will use BigQuery to search our operational data for like similar sounding and spelled names in the sanctioned individual list. Just a note before we go into the demos. Spanner full text search integrates search capabilities directly into the Spanner database. For the demo, we are going to use like a very tiny subset of the features to just showcase the general idea. Because FTS, so our full text search, essentially eliminates the need for a separate search and indexing system and the required ETL pipelines, which also allows you to search like the latest committed data instantly, lowering the operational overhead and infrastructure expenses. Furthermore, it inherits Spanner's core enterprise strengths like providing robust security and compliance, elastic scaling without like latency impact, and high availability to power critical search workloads. Beyond the platform benefit, Spanner full text search delivers advanced search features such as offering automatic language detection, contextual handling of stop words and synonyms, number to text conversions, as well as even like spell corrections. But let's go back to Spanner. So where Manit was so nice and migrated the data over to Spanner. What we want to do is we have a table here, a person table that has essentially two columns. So it contains my customer list, and so it has a primary key and a name here. And what I want to do is add here an additional column that computes the SoundX representation of this customer name. And so this column should get added. So we've got this newly created column based on the SoundX representation based on the name. And of course, I want to make this searchable, or efficiently searchable. So I'm going to add an index on top of that. So this won't take a minute or two to create. While it's creating, I'm also going to prepare a SQL statement because I want to test out if this is working. And to do so, I'm going to place a query here. Just search for like similarly sounding names like my nickname Saps if we have any entries in the database. And yes, so there are a couple of hits of people sounding a bit similar than my first name. And the index is working. Okay, so that one is active. So now I've prepared my data in Spanner and I'm ready to do some analytics with BigQuery on top of that data. And for this part, I'm going to use federated queries to access Spanner's operational data pod directly from BigQuery. And I want to highlight a Spanner feature called Data Boost here, which lets you execute analytics queries and data exports with essentially near zero impact to existing workloads on the provisioned Spanner instance. This is a great way to enable workload isolation on Spanner, so you can run queries against the latest data with this near zero impact on existing transactional workloads, regardless of the query complexity or like the amount of data processed. And this specifically prevents over-provisioning Spanner instances just for ad hoc analysis, which we are going to do in a second. Beyond that, Data Boost is also a great way to power like large-scale data exports, for instance, for migrations. You can fuel operational reporting with it or feed operational data from Spanner into machine learning training. So let's switch now to our BigQuery Studio. And what we have in BigQuery is I've created here an external connection that points to the Spanner database. And I've also loaded our list of sanctioned individuals. So this data set here contains the names of individuals, vessels, including the programs under which they are sanctioned. And this is natively residing in BigQuery, and this external connection is just pointing to Spanner. And what you can do with this external connection in BigQuery is you can query the data and combine it with additional data pods that are residing in BigQuery. So let us test this connection. So I'm firing here a query against my spanner database, just getting like a couple of names from the table if it's working. And it's here including our generated SoundX representation of the names. So, but what I really want to do is to find out if I have names that are kind of similar in my operational database among my customers in the sanctioned individual list. And for that purpose, what I'm going to do is I'm taking the sanctioned individual list and I'm going to join it with the operational data residing in Spanner. So I'm pulling the name and the SoundX representation of all my customers. And I'm gonna join these data sets through the SoundX representation of the names. And as an additional filter, I'm going to take also into account the string edit distance between those names, like essentially what's the difference like in spelling those names. So not just similarity in how they sound, but also in spelling. So let's see what this will output. Give it another minute. And we have here actually a good hit. So there is a name. And by the way, again, disclaimer as mentioned, these are like fantasy names for demo purposes. So we are not highlighting sanctioned individuals here. But what I can see is I have in my operational database someone called Kerschensteiner, which is spelled slightly the same, like a little difference in my SDN list, and it's obviously also sounding the same. So this is someone I actually want to investigate a little bit closer. So for that purpose, I'm switching back to Spanner. And as you can see, I'm a bit lazy, so I'm copy and pasting SQL statements. So why not just go ahead and ask Gemini, because I want to get an understanding, or I want to get an account list for a person named Kerschensteiner. Want to know, like, does this person, like, how many accounts does he have? Let me see. And Spanner actually, or Gemini, generated me here like the right joins between the tables to see which accounts he owns. So this specific suspicious person has 3 accounts with us. And let me see if this person, if he has an audit trail. So I limited the result set to 5, and it looks like there is a lot going on, like with quite high frequency. But what I don't want to do is to sift through like the audit trail manually and create like my own interpretation. Instead, I want to use Gemini to analyze the audit logs directly in Spanner on my data set. And for that purpose, Spanner has a Vertex AI integration with a native interface to access and apply models in your operational database. And with this, developers can quickly apply ML models published in Vertex AI using SQL directly on their operational databases to predict outcomes such as fraudulent transactions or find toxic users, players, or in our case, to get an understanding of audit trails for a suspicious user. So let's do that here. First thing I want to do is I want to register an existing model in Gemini. So in Vertex AI, 2 spanners, so I can call it from my SQL statements. So what I'm doing here is I'm registering Gemini 1.5 Pro as a model in Spanner called Gemini Pro. So this model is now registered and available. And the next thing I want to do is, now that this access is available, I want to call this model on the audit logs. So I'm providing a prompt. So I'm calling here this registered model from SQL. I'm providing a prompt, which is like, give me a summary of this user's audit trail and highlight like suspicious operations. And as a context to this prompt, I'm going to aggregate all the audit trails that I have about this user. So let's see what Gemini has to say about it. And Gemini is highlighting to me that multiple payment methods changed like within a short period of time. There are also address changes, and this raises suspicion of potentially compromised accounts. So I can go and investigate this further. And this doesn't have to be like ad hoc analytics that I'm doing. I could use these models like in an operational transactional setting directly on my data to essentially detect, for instance, fraud near real time, or to raise an alert on the data without me having to take out the data, move it to some inference model, wait for the response. I can do this directly on my data set. And at last, I want to show you an example that I think really nicely illustrates the power and flexibility of Spanner or Spanner's multi-modal capabilities, like in one single statement. What we have here is a query that combines graph search with standard relational SQL utilizing vector search, an AI model, like in one go, in one single database on a single operational data pod without moving data around. So thank you for taking the time and listening in. I hope this session was informative.